Hello and welcome to Rawkode Live. Today's episode, we are going to be hacking and building a GraphQL client and a WebAssembly with Rust. Now, before we get started on that, there is just a little bit of housekeeping. If you have not subscribed to the YouTube channel, please do so now. You can click subscribe, click the bell, and you will get notifications for all new episodes of Rawkode Live, where we'll be exploring the cloud-native landscape and providing learning materials for us all to get through this mess together. Also, if you want to chat and like to chat, there is a Discord channel available at rawkode.chat. Come and join us, say hello. We talk about cloud native, Kubernetes, and all things in between. That is it. Nice and easy. Now, in order to help us on our journey today, I am joined by Connor and Francis. Hello, both. How are you today?
Doing good.
Well, thank you for joining me. Do you want to start with a little bit of an introduction? We'll start with you, Connor, just because you're next to me. And then Francis, if you want to take over and tell us a little bit about yourself.
Yeah, I switched headphones last second there. Can you still hear me all right?
Yes, we can hear you. All good.
Okay, great. Yeah, so my name's Connor. I created the Suborbital family of open source projects. I've been a Go developer for a long time, but for the last year and a half or 2 years, I've been delving into the world of WebAssembly, trying to build cloud native specifically around WebAssembly. And so the Suborbital family of projects is my way of, building the ecosystem around WebAssembly that I, want to use as a developer myself.
My name is Francis. I've been a JavaScript developer for, I don't know, 10 some odd years. And I've been making a lot of serverless web apps for, professionally for a while now. And so recently I joined Shopify to work on a WebAssembly platform, which is a lot of overlap with Suborbital, and that's how I met Connor. And I'm a big fan of GraphQL in serverless environments.
Awesome. Thank you both for sharing. Yeah, I've got to say, I'm really excited too. I'm going to be honest, I have no idea what we're doing today. But whenever I hear WebAssembly, GraphQL, Rust, I'm immediately sold and just want to start having some fun. So, Connor, you had this idea. Do you want to give us a little bit of a context on what we're going to do?
Yeah, for sure. So with the, suborbital open source libraries, one of the things that people have been requesting of me since the projects have been out in public is the ability to make calls from a WebAssembly module running inside of Reactor or Atmo, our two main projects, out to a GraphQL endpoint to be able to fetch data from an API like GitHub's API or Shopify's API or whatever. So I thought, you know what, I've done a little bit of GraphQL in the past. I'm not the most, experienced person with it. So why not, go a little out of my comfort zone and try to build this thing live on the air and try to get our WebAssembly modules talking to a GraphQL backend and see what happens.
Now, for people who may not be aware, why isn't this as easy as just getting an HTTP client and using it?
Yeah, so things get a little tricky when trying to have a WebAssembly module that communicates with the outside world because there's a sandbox around that module that means that the module is not allowed to just do whatever it wants. The host system has to actually grant it the ability to do anything really. So we have to allow these modules to access the outside world in a safe way by actually defining these capabilities on the host side and then making them available to the module.
It sounds tricky.
Yeah.
And it sounds like maybe there's not a standard there yet, which means like that we can't like say, oh yeah, turn on network, and then now it can make these GraphQL calls, or is that not or is there a reason why we don't want to do that?
So there is an up and coming standard that's being adopted more and more in the industry called WASI, which is the WebAssembly System Interface, and more capabilities are being added to that all the time. But not everything's available just yet. It's not fully comprehensive. And so, we're going to try to build something that would maybe end up in WASI one day, this interface that we're going to build today.
Yeah, I think if I remember correctly, the last time I looked at WASI, they didn't actually have BSD sockets yet, right? There's no networking.
Yeah, there's some proposals in flight that are currently working on adding all of that to WASI, but not quite yet.
You just like
And
making
do
things
we
difficult for
want
yourself, right?
and do we want a full network? Like is that what we want to expose for this GraphQL project today?
We don't. We want the host to be able to have full control over what these modules are allowed to do. So the sandbox that I talked about before, it's designed to be denied by default. So, if you just instantiate a WebAssembly module with absolutely no, pre-configured capabilities, it can do nothing. It can't, reach outside of itself in any way, shape, or form. We want the host to be able to say exactly what these modules are allowed to do, and preferably be able to programmatically configure that when we're running our application. So we're going to try to make all of that happen today.
So
So
for our client, would it be an HTTP client that we were making, or would we want to make something GraphQL specific?
So Reactor already has a generic HTTP client. I want to create something that's very specific to GraphQL.
All right.
Yeah.
okay, so I
Um,
I, I think I understand what's happening here, right? Because the WebAssembly doesn't have these primitives baked in, we're going to be adding this to the Reactor project, which is going to expose hooks somehow to the WebAssembly to be able to make these calls. Okay. Now,
that's right.
for anyone that's not familiar with Suborbital, Atmo, Reactor, etc., I'm going to show the website here, but can you give us the overview?
Absolutely. So Suborbital is a collection of open source projects, and there are three that I refer to as the building blocks. So that includes Reactor as well as Vector and Grav. Vector and Grav are networking libraries for Go, for HTTP servers and async communication. But Reactor itself is a job scheduler. So it's designed to take tons of jobs as input, and then it'll create workers internally to efficiently handle all of that work. And one of the ways that you can create a Reactor worker is with a WebAssembly module. So that's how we're going to go about it today. And then I call it the batteries included project, is called Atmo. And this builds on top of those three building blocks to create a more user-friendly version of WebAssembly as a cloud native platform. So it allows you to define full server API applications with a declarative file called the directive, and then it uses WebAssembly modules to actually handle the different things that you describe for that application. So we're going to be working at the Reactor level, so it's actually one level down from Atmo, because that's where all of the WebAssembly internals happen. And then hopefully the goal is that I'll be able to import all of that functionality we build today into Atmo, so that you'll be able to get the advantages of this GraphQL client in either one, whichever you prefer to use.
This
Sounds
sounds
impressive.
very familiar to what we're building at Shopify, which is actually one of the reasons why we know each other.
Yeah.
So
You want to share a little bit about that as well?
yeah. So we have this scripts platform. We just announced it at Unite a few days ago, which is Shopify's big developer conference. All that stuff's up on YouTube somewhere. You'll be able to find it. Check this, I think, shopify.eng on Twitter. And we have this problem where our stores get a lot of traffic, and we have third-party apps, and they have their web servers, and they run, and they talk to our API, and that's great. Except when you get a lot of traffic, they can fall over if they're in the critical path. And so we have to keep them out of the critical path of like very performance things, like checkout. So we have this project, this app called Scripts. If you're a large merchant, you get to use it to customize your checkout, and it runs code on our servers during checkout, and we're able to do that by sandboxing using much older technologies than WebAssembly. Well, we have this new checkout, which we talked about at Unite, that's significantly faster. We can do as much traffic as we did on the entire platform during Black Friday, Cyber Monday, like in one store, like on the new checkout platform. And that's like what is it? over 200,000 checkouts a minute or something like that. So we want to make sure we can scale this customization part too, and so enter WebAssembly. And so we want to take scripts compiled into WebAssembly and execute those to customize our platform, for your stores, during checkout. And honestly, I want to see a world where you write your app to run on Shopify's infrastructure, and it's not, it's like our APIs are APIs, but like WebAssembly can run anywhere, and it can run, well, as we talked about, safely, and sandboxed. So anyway, there's just a lot of overlap here, and the better the ecosystem and the better the tools we have, the better the tools we can provide, and capabilities we can add to our platform. So anyway, that just makes me very happy.
Awesome. Well, it sounds like you are both extremely qualified for today's task at hand, so I am going to sit back and watch. And I'll do my best to probe with questions as we go. Let's get started. What's step one here, Connor?
So we're going to start in the Reactor code base, and there's actually 3 layers that we will need to concern ourselves with. There's the actual code to make the GraphQL request. That's step 1. Step 2 is defining the interface that the host exposes to the module and making sure that the module can provide all of the information that it needs to provide. And then the third step will be actually switching gears over into Rust to actually consume that host API. So we're going to add, some capabilities to the suborbital Rust library that can actually call into that host function and take advantage of what we've built.
My Go is not any good. My Rust is okay. It's definitely
We're all here to
there,
learn
but
from
I got
each
opinions
other.
on GraphQL APIs, or on APIs for this.
Right. Cool. So we're going to start in the capabilities.go file inside of the RT package. If you want to open your tree up there, or you can. Oh, are you able to follow me? Oh, that's even better.
Yes.
It's been a while since I've used this fancy VS Code plugin, so this is awesome. All right. So right here is what we call the capabilities struct. So this is a collection of things that WebAssembly modules are allowed to utilize when they're running inside of Reactor. So as you can see, we've got a couple here. We've got a logger, we've got an HTTP client, we've got a file source to access host files, and then we've got a cache. So we're going to be essentially adding to this list here, and we're going to be adding a GraphQL provider to this set of capabilities. So we can maybe start by taking a look at the simplest one, which is the logger, so that we can, actually the logger is not a good example. Let's look at the HTTP client. The logger just provides a logger object. That's not as fun. So it's really quite straightforward. The interface is just exposing one function, and that is, take in an HTTP request and provide either an HTTP response or an error. And because Go has its entire, networking stack completely built in, that amounts to one line, to call the HTTP built-in client, right? But this part is only, it's actually the most boring part of what we're going to do today. Making the GraphQL call from Go is not actually going to be the hard part. The hard part is going to be defining that interface between the host and the WebAssembly module. So, this is going to be somewhat similar to what we build today to make a GraphQL call. But let's take a look at what that interface would look like so that we can get an idea of what we're in for. So
should I talk a bit about what GraphQL expects?
Yeah, why don't you do that?
Or we want to talk at a lower level first?
Yeah, well, if you want to give maybe an overview of what GraphQL is designed to be used for and how maybe it's structured, that would be great.
So people always get mad when I make this comparison, but have you ever used soap? um, so if you have, you'll understand. But basically, there is an HTTP endpoint. You can post to it. Sometimes you can get to it. GraphQL actually doesn't care how you get to it. It wants a couple things. It wants a string that is a query. It wants a hash that is your variables for that query, if any. It wants an operation name, because your query can define multiple operations. And I was actually just looking at some other stuff. There are extensions, so some servers will take other inputs as well. There's a whole file upload extension, all sorts of things. But at the end of the day, it is a couple things in, mainly query variables and operation name, and then you get an object out. And they don't even declare it has to be JSON. 99% of these things are JSON. I've seen message pack and other stuff. But that has two keys, data and error. And so you get query variables operation name in and data and errors out. And that is like the basic API. People take this, put it over WebSockets, made GraphQL subscriptions. They've also taken this, put it into GET requests, and now you can have cacheable kind of get for query only GET request kind of things. And there's a whole slew of extensions from Apollo and a dozen other companies out there trying to make a big in GraphQL. But the very basics, which is probably where we should start, are those three inputs and two outputs.
Absolutely. So we're probably going to be doing something fairly similar to this today, which is why I want to kind of use it as the example. So this is a generic HTTP interface. So, where we started with that HTTP client, this is the actual Go implementation of the HTTP client, but then we need to define the, how the WebAssembly module will tell the host that it wants to make one of these requests. So we'll take a look at this portion of the Reactor project. This is where we define that interface. So one of the quirks of WebAssembly is that you can't take a Go variable and pass it and expect that Rust understands that Go variable. You need to serialize any information that you want to pass in between the module and the host so that they can understand each other. Now, again, WebAssembly is evolving, and so there are some standards that are being put in place to be able to actually natively share memory in the way that would be, maybe a little bit more efficient and a little bit easier to understand. But as it stands today, we're going to be doing some serializing in order to pass information between. So in Reactor, when you expose a host function to the WebAssembly module, we define it and it looks something like this here. So the fetch URL host call takes in a whole list of parameters, and I'll kind of go through them each. So first we ask, okay, what's the HTTP method that we're going to be doing? And that is a set of constants. We either going to do a get or a post or a patch or delete, and those map to numbers 1 through 4. So that's number one.
Why do
we define
numbers?
those constants?
Yeah.
Because we want to minimize the amount of serializing and deserializing that we have to do there to be a little bit more efficient. So anything that we can map down to a simpler data type is usually a good idea.
Okay, so there's no restrictions on the kinds of data types, though. So if we really needed a string, we could get that string, and I'm assuming that's what how the URL pointer works.
Kind of. So WebAssembly naturally does not have a string type. You can't define a string. But individual programming languages do have a string type. So what do we do there? How do we get a string to kind of traverse that boundary between the host and the module? And in order to do that, we write the string to a particular piece of memory, and then we pass a pointer to that memory in either direction so that you know where to find it. So when the WebAssembly module asks the host to fetch a URL, it is going to include a pointer to the string in memory where it can find that information, and then it's going to tell us the size of that memory as well, so that when the host receives this function call, I'll cover in a second how it can actually go and ask the module, hey, give me this memory at this pointer so that I can figure out what URL you were trying to tell me about. And then we do the same thing for the HTTP body. So it's these kind of pairs of data types that we're going to be passing in order to accomplish this. It's a little bit kludgy, but the advancement of the WebAssembly standard is going to mean we don't necessarily have to do this anymore once things get a little bit more, a little bit further along. So
now, can I guess this is completely safe to point to arbitrary places in memory?
Not always. So WebAssembly defines linear memory. So there is actually globally exported blocks of memory that the host is allowed to dig into and grab. So we have to define a contract between the module and the host to say, you should be looking at this piece of memory in order to safely, communicate with me. You can't just go arbitrarily, poking around in there. And so part of what Reactor does for you is kind of handles that all for you to ensure that it's being done safely and you're not just arbitrarily messing around in the memory of the WebAssembly module.
Makes sense.
Yeah. So in order to reconstruct that memory into a string, we have a couple of helper functions that are inside of Reactor. So there's this read memory helper function here that allows us to take that pointer and the size variable and actually pull that information out of the WebAssembly module as it's running. So the WebAssembly module exposes its global memory to us, and we can use that, the pointer to access the data at a particular point, and then we can read the data to a certain endpoint. And then, because of the interface we've defined, we're interpreting it as a string. So once we have read that memory out of the WebAssembly module, we convert it to a string so that we can use it as a URL, which is the thing that this function is actually attempting to do. Cool. Any thoughts or questions from anyone at this point?
So I've learned a lot in the last 5 minutes. I think it's really cool. So if I understand this correctly, we have to define a Go interface that kind of prescribes how the WASM side of things knows how to make this request by enumerating values. Like maybe it's a GraphQL query as a 1, a GraphQL mutation as a 2, and then we have the ability to use pointers and memory space to actually squeeze in the query and then execute it, and then do the same in reverse to get the result back. It's kind of where I think we're headed.
That's exactly right. So you kind of you got to the end pretty quickly there, in that what we're going to end up doing is we are going to write the result back into the WebAssembly module's memory. Once we've completed the GraphQL request, we're going to use this helper function here, which actually writes the memory, and then the module, once the function call completes, the module will then go and read that memory to reconstitute the result on the other side. So you'll see this acronym FFI throughout the code base. And FFI stands for foreign function interface. So when we talk about crossing that boundary between the host and the module, we call that an FFI, a foreign function interface. So that it's basically the idea of how do we translate the function call across that boundary and make it so that it's a properly defined host call, essentially. So when you see that FFI terminology,
host and module yet. So if I had to take from context, host is the fully, the process is running on an operating system. It's the thing that executes the WASM module. Is that correct?
Yes, that's right. So Reactor, when you use the Reactor library and you run a Go program that uses the Reactor library, that process is the host. And so because it's just a Go program, it has access to the whole wide world of anything, network, files, whatever it wants to do. And then the module, which is the WebAssembly program that we have compiled, gets loaded into Reactor as a child or as a guest. And then that guest module is allowed to communicate with Reactor over this FFI that we define here. So this fetch URL function is just one of the FFI functions available to the guest module.
And you said something that and it looks like actually we have some questions in chat, but you said something that maybe is important, maybe it's not. You said when the request completes, we tell WASM. Does this mean that there's some sort of asynchronous exposure to WASM, like from our WASM code?
So everything in WebAssembly is synchronous. There is not yet the concept of threads or asynchronous execution in WebAssembly. So this is all actually happening in sequence. So the order in which things happen is Reactor loads the module and starts to execute it. Then the module makes a function call to the host. The host performs some kind of action, like making an HTTP call, and then the host relinquishes control back to the module, where it can then receive the result of that function.
And so our code in the module says, "Hey, get me this GraphQL API," and it's like, "Oh, I got it, thanks." You know, it just gets it synchronously.
That's exactly right. And yeah, and because WebAssembly doesn't support any kind of threading, Reactor kind of helps you with that, because Reactor is able to run dozens or hundreds or thousands of WebAssembly modules all at the same time. You can actually almost achieve threading by just running many copies of that WebAssembly module all at the same time. So Reactor helps you do that by creating pools of workers to accomplish different tasks in a multi-threaded way.
All right. Can we tackle a couple of questions from Reza, and then we can get into some coding here. So Reza asked, are you using TinyGo or Go?
So for the host, for Reactor itself, that is written in Go proper. And if you wanted to run Go code as one of the guest modules, as an actual WebAssembly module, that's when you would probably reach for TinyGo, because TinyGo has a really good WebAssembly toolchain that is quite honestly better than the regular Go toolchain in a lot of ways.
And there's a follow-up that says, how do you know which memory space needs to be accessed? Are there any tools?
Yeah, so technically WebAssembly modules can export multiple memories. It's an interesting concept that I haven't fully taken advantage of yet, honestly, but there is kind of a main memory, a global memory that is exported by every WebAssembly module. And so for Reactor's case, at least, we only use that main memory module. But maybe in the future, I'll find some use case for having multiple kind of individual memory exports.
Awesome.
Does this mean it can export its memory safely? As in, like, if it doesn't trust the host?
Yeah, so it's usually the trust relationship is in the other direction. So usually it's the host mistrusting the module. There's, it's not really designed for a module to mistrust the host. I'm sure there's ways you could do that. Smarter folks than myself would need to figure out a way to do that properly.
All right. Well, I think, Reza, you'll hopefully, as we dive into this and write a little bit of code, that the pointers and size will become a little bit more apparent to you. So let's move forward and get some code working.
Yeah. All right.
I actually think I got an answer there. I believe there's just a fixed pointer size in WASM. Is that right? There's a fixed memory space and a fixed pointer size that
That's
everybody
right.
needs
So
to use.
Yeah, so the fun part about WebAssembly is that, so I mentioned that it's linear memory. So memory in a WebAssembly module is essentially just a gigantic array, and you can access that array at different points. And so when you pass a pointer from a WebAssembly module to the host, you're basically just telling the host, hey, access my gigantic array at this particular index and read it for this number of bytes. And so it's actually pretty cool.
Great.
All right. And I guess we should take a quick look at the host code first before we move on. So I want to show kind of the matching WebAssembly internal call. So we looked at the fetch URL call on the Go side, but if we switch over to the Rust side of things, this is going to be the code that gets actually compiled and put inside of the WebAssembly module. So in the suborbital Rust library, we define an HTTP module, and inside of that module, we actually define an external function with the exact same signature as the host function. So when we are inside of the module, we can call this function, and it will directly map to the host's version of this function. So when this code calls fetch URL, what it's really doing is asking the host to run this host version of itself. So that's how that communication happens, and we'll probably dive into that more in a little while. But yeah, we can choose either Rust or assembly script, whichever we want to go with today. I'm cool with.
My vote is
I'd
on
much
Rust.
prefer Rust.
Yeah.
I think that's the more fun option for sure. All
So
right, so
is step one here to define the host interface then?
yeah, that's right. So we're going to create one of these capabilities that is just Go code to make a GraphQL endpoint. So I'm going to create a GraphQL.go file, and we're going to start from scratch. We're doing this from nothing. We have written no code yet. So this lives in a package called RCAP, which just stands for Reactor Capabilities. And we have to get started here. So we want to start with, do one of you want to do this part? I'm happy to let one of you type.
I think like just like deciding the inputs and the outputs might be an interesting thing, because I know how we would do it, like from Rust. If I were to have a Rust function, right, a method that like takes GraphQL input and output, I would I know what I want that to look like, and I'm curious how to translate that to our host our host module interface.
Cool.
So
So
like,
why don't we sketch it out in pseudocode here, and then we can actually get to writing the proper Go code.
I'm wondering if this is if you're seeing this. I got Copilot running on my machine. No, you're not seeing this, but it's really crazy the stuff it's trying to do for me. Okay, so I know where you have a query. I know a query is a string, right?
Yep.
And I know we're going to have variables, and I know variables is going to be an object, a hash. So this is going to be like a JSON object. Really, though, like everything all together, and we have an optional operation name, which is also a string. And I guess variables is also optional. So like, this is my TypeScript showing, but the whole thing actually is going to get to JSON in 99% of the GraphQL servers out there. So maybe our only input is a string.
Yeah.
I don't know.
So I think the only thing we're missing here is the endpoint. Right? We need to know where this thing is going.
Yeah.
Now, one of the
method,
questions will be, do we want? Yeah, you're right. So the question is, do we want to instantiate the object with a predefined endpoint, or do we want the module to be able to pass whichever endpoint it wants when we make the host call? And we don't have to decide now. Cool. So we're going to want to create some a Go struct to kind of help us along here. So we'll start with GraphQL client struct, and it's gonna want to have an HTTP client as one of its internal fields. But other than that, I mean, there's not a whole lot that we need to add here. So we're gonna make sure we comment our code well. Is a GraphQL capability, I can't type, for Reactor modules. Great. So we're going to, oh yeah, that's right. So errors are as an array, right? Okay, you're way ahead of me.
Yeah.
Awesome.
Sorry.
So I think the first thing that I would do when I'm approaching this is I would, take, we've defined pretty well what our input is here, and we should define what it is we're sending to the GraphQL server. So I usually start with a request type. So if we define a GraphQL request type, that includes our query, which is a string, and that goes out to JSON as a string. And we include our variables, which is in Go, it's called a map, so a map of strings to strings. And that will go into JSON as variables, I believe, if I'm not mistaken. And then that operation name is a string, and that goes to JSON as operation name with that capitalization, I think.
Yep.
And since it's optional, we're going to add this omit empty directive here, so that if we don't provide one, it's just not going to include it in that JSON output.
Variables too is you can omit empty.
Oh yes, you're right. So keep our code nice and well commented. Is a request to a GraphQL endpoint. Cool. So we've kind of defined now, we're going to be sending this to the server, and now let's define what we're going to get back. So a GraphQL response looks something like this. So data is, I'm assuming that's going to be bytes.
It's going to be a JSON object or null, or JSON null.
I see. Okay, so then I guess it would probably be a map string interface. That's usually how I define just some unknown JSON blob, and that is an actual key called data, right?
Yeah.
In the response, great. And then our errors are an array of the array of an object that looks like this. Is that right?
Correct.
Message path and type. Cool. So we'll probably want to define that as its own structure here. So if we define a GraphQL error, and oops,
I gotta tell you, it's not standard. The message and the path is standard. Every server gives a little extra.
Gotcha. Cool. So we'll define what that GraphQL error looks like, and we'll define the path, JSON path, and then we'll say that the errors is an array of GraphQL. Man, I need Copilot to give me better suggestions here.
You can thank Copilot for the definition of errors there. He just did it.
Nice. All right. Oh, there's no colon there. Okay. How's that look? Am I missing anything?
No, the format are kicked in, so it's looking good. That's how I know if my code works.
That's right. For anybody who's not familiar with writing Go, there's a tool called GoFmt or GoFMT that runs every time you save a file, and it will apply a standard set of formatting to your code. So, for example, all the spacing here, lining up these backticks so that they look pretty. That's all done automatically for you. So it makes you it makes your code even prettier than what I'm usually willing to put effort in for. All right, so
I think I'm not sure if data and errors are both always there at all times. I'm looking up the response format like spec right now, but if that doesn't really matter as much, we can figure that out later.
Yeah, it's never a bad idea to include omit empty. There is no harm in doing that. All right, let's keep our code commented. Is a GraphQL response.
Yeah, data should. According to the spec, data should always be there, but sometimes it's null. If there were errors, it'll be null.
Gotcha. All right.
We got a comment from Noel saying we have a typo in our message JSON definition.
Message JSON. You are correct. Good catch. That would have been real annoying when it goes to unmarshal the JSON and we find that our message is always empty. Good catch. Good catch. All right. So those are our inputs and outputs. So now we need to actually, define that function that will do it for us. So we're going to create a function that operates on the GraphQL client, and the HTTP client calls it do. So I'm just going to call it do as well. And so this is where I'm maybe going to ask Francis what the best, the best practice is here. Do we want to have query and mutation defined as specific types, or what do you think is the best thing to do there?
No. So your query document can include mutations and queries and anything else your server might support. So I think the difference in the result is nothing. The difference in the input is nothing. So I don't see them as being different methods.
I see. So you actually specify that inside of your query string, is that right?
Exactly.
Okay, cool. So then I guess we'll just start with.
You'll find a lot of, and I don't know if this translates for us, in like the React world, all the hooks, you'll find different like methods for query and mutation, only because queries you probably want to execute right away, where mutations you want to choose to execute later, like you want to set them up and then use them. And that might be the only reason we want to do that, but I don't see why this interface would include that kind of concept.
I didn't know that. That's really useful. I thought that you had to send queries over a get and like mutations over a post. That's just what I've seen in other libraries, but today I've learned.
I've seen different things in different places.
Under the hood, mutations are actually a mutation in the input and then a query. And so it's actually like it's like at the end of the day, the output is always a query. So it's the same operation in GraphQL.
Oh, Reza pointed out another typo here. This is not going to be called string in the JSON. This is going to be called query.
All right, the audience are
sometimes
right.
Sometimes my fingers work faster than my brain.
We need the high find to live code.
Yeah, exactly. All right, so this function is going to either return a GraphQL response, or it's going to return a GraphQL error. Now, in Golang, I usually don't like to return a concrete struct type as an error, so we're going to return the generic error type, and we're going to actually make GraphQL error conform to that type by just giving it the one method that it needs. So
in which case, our GraphQL response doesn't need to include errors. Or does it?
Oh, right? Good point.
I think
we're not actually returning that directly. No, I think you're right. So what I would tend to do is that if this is populated in the response, we would just return an error here and tell them to look inside of the errors array. So you make a good point. We're not returning this directly. We actually have an array of them inside here. So yeah, that's a good point.
I believe it's a choice of the two. Sometimes if there is an error in the execution, to include partial data as well. So a field can error and you still get the other fields.
I see.
And so
I see. So you can still have a usable response object. Okay, cool. So I guess for now, let's include the endpoint in the actual function parameters. We may choose to pull this out and make it specific to the client object later, but for now, let's just let you pass both in one go. So for those of you who are like myself and are fairly new to GraphQL, it's really nice that GraphQL queries are really just HTTP requests. So we can get away with using Go's built-in HTTP client to accomplish a lot of what we want to do here today. So we're going to build an HTTP request. We're going to send that HTTP request off to the endpoint that's defined here, and then we're going to parse the response. So to start, we're going to create that request object by using the HTTP package, and that has a new request method inside of it. So here is where that that spec ambiguity can maybe cause us a little bit of pain. So we need to choose our HTTP method here. And
What
so I'm gonna.
would it be simpler for us to assume it's a post with no headers just to get it going and then add it in later?
I think that's the right call. So we can start with http.method post here. And yeah, like you said, that's the simplest way. And then maybe we can make it fancier later if we have time. So then we're going to pass in that URL. So this is going to be our endpoint. And then we're going to pass in our body. So we need to actually construct that body. In Go, we use this, it accepts this io.reader type, which is an interface that just expects you to be able to read data from it. So we need to build something that conforms to that interface. So in order to do that, we need to figure out what's going to go in it. So we're taking in the query string, which is going to be placed inside of this field in the GraphQL request. So we need to actually build this request object before we can kind of continue. So let's create a request object that is of type GraphQL request, and we're going to stick some data into it. So the query is going to be the query that was passed into us here. And then to start, I think our variables can be empty. So we'll just create a map string to string that has no data. And then the operation name, I think it's also optional. So actually, we'll exclude that because it has that omit empty operation on it. Technically, we exclude both of these, but just for illustration purposes. So then in Go, when we want to take a struct and create JSON from it, we use the JSON package. So we're going to call, we're going to say that the request bytes is JSON.marshal, which is the equivalent of JavaScript's to JSON or JSON.stringify. I can't even remember what it is at this point. And we're going to pass in that request object. Yeah. And then we're going to check our errors here so that if the JSON was poorly formed, we could catch that before we try to send to the server. So this errors.wrap, for anybody who's never seen this before, this is something pretty unique to Go, I think, where we want to make sure that we have some indication of where this error originated. So what we're doing is we're taking the error that came out of this function call and we're wrapping it in a message saying where that kind of failure came from. It just is a habit that I've picked up. Whether or not it's standard practice, I don't know, but that's just how I've always done things.
This is actually a feature that's coming to JavaScript pretty soon too. I think probably because of Go, but just like adding that more context and keeping the original error behind, or having multiple errors that you want to send as one, like it's just a common pattern. And so I'm happy it's got language support here.
For sure. Cool. So now we've got bytes, a variable containing bytes, which is our JSON. So we're going to, as that last parameter in our request builder, we're going to use the bytes.new buffer, which is, it takes those bytes and loads it into that io.reader interface we were looking at before. So the rec bytes will go in there. And now we have a request. So we're going to do the same thing. We're going to do a similar error checking for this call, but instead we're going to say failed to new request. And then we have a request object. So we can take a quick look at what that looks like for anybody who's unfamiliar with Go. The HTTP request in Go is just a method, and the URL that you're making that request to, a bunch of stuff that I don't care about, some headers for the HTTP request, a body, which will be the request body for our post request, and then some other metadata like content length and some, if you wanted to use a form request, you could do that, multi-part, etc. So lots of fun stuff in there that you can take advantage of, but we're doing a pretty basic request today. So we're really just going to be including a buffer that includes our request. And then we're going to want to add a header. So just to specify the content type, I believe that's standard practice, if I'm not mistaken, with GraphQL. So for the rec.header, yeah. So we're going to add a content type Now, I've seen conflicting reports. I've seen application JSON and I've seen application GraphQL. So do you want to set me straight on what I should be using here?
I mean, it's not in spec, it's whatever the server wants. Application JSON will work everywhere as far as I understand it though.
Gotcha.
Because like
All right.
most clients are setting that because they're sending JSON.
Understood. All
Yeah,
right.
I think the
Nice.
application slash GraphQL is if you want to send the raw GraphQL query, right? Without actually changing it to JSON.
Without
cool.
wrapping it in this struct, you mean?
Well, yeah, like, you know, so like a GraphQL request would be like query. I can't remember the exact syntax, but all posts name. Like you can send it without JSON, without converting that to JSON as GraphQL, depending on the server, of course.
Awesome.
But we don't need to worry about that today. Let's just do JSON.
Yeah, fair enough. All right. So then what we're going to want to do is we're going to actually want to make that request. So we're going to do we're going to take the HTTP client that we added to our GraphQL client, and we're going to actually use it to make an actual request. So we're going to do g.do. Oh, that's going to be confusing. We should actually call this client to prevent making any mistakes. If we have a do function on this and a do function on the HTTP client, we could run into some issues here. So we'll do g.client.do just to be very specific about what we're trying to do here, and we're going to pass in that HTTP request object that we created up here. So we'll do the same error checking right here. We're going to return nil and failed to do. And then we're going to do something with this response. So that response contains, hopefully, if everything goes correctly, that is going to retain something that looks like this. So we want to actually take the raw response and we want to load that data into that struct. So we're going to create, we'll call it GQL response, and it is going to be a GraphQL response object. And then we're going to use that same JSON package as before, but instead of Marshall, which takes a struct and turns it into JSON, we're going to do the opposite. We're going to use unmarshall, which takes JSON and turns it into a struct. So we're going to unmarshall the response.body into the GQL response. And we're going to be a good best practice for Go is we're going to close that that body similarly to how you would want to close a file. We're going to close that body when we're done with it. And we're going to check the error on that as well.
Of course.
There's a lot of this this stanza repeats itself a lot in Go code.
I've got to say, I'm really impressed that you haven't, like, whenever I write Go code these days, it's 50% Go and 50% Rust, and I always have to go back and fix it. You've not typed FN once, or...
That's me when I'm writing Rust code. I will very often accidentally write Go code while I'm writing Rust.
Yeah, I always write
I just realized
stop print or print ln in the wrong language all the time. It's so annoying.
Yeah, I just realized we missed a step. We need to do response. We need to do response JSON is IU tilde read all response.body. We need to actually extract the raw bytes out of that first. I should really put this error not nil into a into some kind of snippet.
Yeah.
It's become basically. Yeah.
Use snippets. You're gonna have some copyrighted code in there.
All right. So now we've made the request. We have read the response out of here, and we're gonna actually do the right thing here. So we've read the raw bytes out of that response, and then we're taking the JSON package to actually convert that JSON into the GraphQL response type. So if we've gotten this far and nothing has gone wrong, A, I'll be shocked if it works on the first try, and B, it means that we're done. So we can actually return that GQL response and a nil error to say that we are done. So yeah, Reza pointed out that http.newRequest is not available in TinyGo, and that's exactly correct. So because when we talked about earlier that WebAssembly doesn't have a native networking stack at all, pretty much the native network library for any programming language won't just work out of the box inside of WebAssembly. So that's why we're creating these interfaces so that we can basically ask the host to do these complicated networking tasks on behalf of the WebAssembly module instead of trying to do it from within the module itself. All right, what is this complaining about? Nor custom. Oh, that's right. In order to do proper JSON marshalling, we need to export all of these fields. That's something that I always forget.
That was a comment earlier from Rude, which I didn't understand, and now I do. It told us our struct fields aren't exported.
Yes, that's probably why it had the yellow squigglies before. All right, cool. So I think we have got a very basic GraphQL client here. So do we want to try it out and see if it actually works?
Nah, that's good. Let's finish.
All right. Well, it's really nice hanging out, y'all.
Like, are you sure you want to just leave it here?
Let's do it. Let's see if this works.
Well, do we have
All
a
right.
GraphQL API out there that will take an unauthenticated post and give us some data?
I do.
I think David might have something. Yeah, cool. So I'm going to quickly create a QL client. I'm going to quickly create a constructor for us here, and then we can get to it. So we're going to create that GraphQL client. We're going to call http.default client, and then we're going to return G, and that is going to be the GraphQL client we're looking for. So now we've got a constructor to actually create this client, and we can actually try to use it in Graph. Why is GraphQL client so hard for me to type? Not quite sure. Okay, so did one of you want to try actually using this thing? I like to
Where do we start?
I like to create a tester file here with a main.go, and I will create your I'll create your main function for you, and then I'm gonna let one of you two go crazy and
It's gonna have to be you.
try
I
to use
don't
this
know
thing.
Go.
David, I think you need to take a stab at this.
I wish I was paying more attention, but sure.
Let's throw out there. Pokemon test servers are the best. Thank you, Reza.
All right, so we want to be able to consume this new GraphQL client, right?
Mm-hmm, that's right. So we should be able to import from the RCAP package that, so it'll be rcap.new GraphQL client. Mm-hmm. So for Go, we're going to need the fully qualified import path.
Oh, yeah.
Rcap, just like that. So that should be cool.
And it doesn't return an error. Yep, it just returns a thing. So now I can do client.do.
Yeah.
And I can call my endpoint.
Yeah.
And I can pass in my query, which I'm going to jump over here and get one. So this is this is an API that I'm trying to move all of the episode data and stuff like that to GitHub and then publish this API so that it can be consumed by anyone. So there's not a lot in it, but there's enough to get it started. And then as we got in the comments, there is Pokemon APIs we can use too.
Yeah. If we want to get into the Pokemon APIs, I'm definitely interested in that.
All right, so why don't we just pull down profiles, and then we'll grab my name. It should come down.
Pokemon APIs are the best hello world of GraphQL.
Not to-do apps? I thought it was all about the to-do app, no?
No, they're better. There's so much cooler data.
Yeah.
So is this correct?
That looks about right to me. So that do function is going to return either a response or an error. So you got to assign something to it. Exactly. That's right. So then we can do the good old error check, and we can see if this thing works. That's exactly right. So then if it is successful, then we should be able to maybe just print response.data or something like that. And see what happens. Data would have, yeah, there you go. Okay. That's not complaining on my end, so why don't we give it a try?
Print in the error, print the error.
Oh yeah, we should print the error. That's right, on line 21 there.
Oh.
Actually, you know, we can do an alternative to os.exit. We can do log.fatal, which allows you to actually pass in the error as a parameter. All right, shall we try to run this?
Let's do it.
Yeah.
Do you have
terminal?
the Go tool chain? I don't know. I haven't used this share thing in a long time. Do you want to try to pop one up? Yeah. There you go. Do you have the Go tool chain installed?
Yeah, you'll need to give us
it's running
access
on your machine.
Yeah, you should be able to run it here, and we should be able to
will it show you?
If you use the same terminal, we have two right now, so don't type in your first one. I guess I could just click on. Oh, no, wait, that's my terminal. Yeah, if you click on the shared terminal.
Oh, okay. I don't even see that. Let me find it here. Oh, there it is. Shared terminal. Is that?
Yeah, there we go.
Oh,
ASDF.
There we go. All right, cool. This is awesome. I love this live share thing. All right, so we're going to go run this thing. So we're going to do our cap/tester/main.go, and we're going to see if this works. Hey, look at
Fingers
that.
Crossed.
It worked.
We're getting some data.
Woo!
Even though you had me type it. Oh, that's.
That just goes to show that the library is really solid.
And ship it.
Can we do this again? Let's make an error. I want to see what the errors look like. So if I do all profiles z, I save that.
Yeah.
And then
I'll execute it again. Oh, it looks like it didn't detect the errors. So that seems like a bug in our end. Well, why don't we check out what's going on there?
I'm curious. We may get one of several errors here. We might get a 200 response with the errors array. We might get a 400 response with the errors array. We might get a 500 response with the errors array, or we may get nothing. You know.
Right. All right. Well, we can account for all of those. Do you want to follow my cursor again, David? And we can try to add a little bit of robustness to this thing.
Following.
Yeah,
Yep.
There we go. So what we'll do is once we've gotten this response back and we've kind of read the data out of it, we can actually go and add some extra checking here. Do you want to deselect that text maybe? There we go. So what we can do is we can say if the response.status code is not a 200, or we can say is greater than 299. That's what I usually like to do. Then we can return actually we want to do this after we've parsed the JSON.
Okay, so the problem we never got the error there was because the GraphQL server is actually saying 200 okay, and the errors in the response, which is why we never got the error handling. Got it.
Exactly.
And so if errors is not null or undefined or whatever, that's when we know we have a GraphQL error. There still might be GraphQL data, but that's when we know something bad went happened. Like hands down across every server.
So what we'll do here is we'll say else if the GQL response dot errors. In fact, did we make that omit empty? I can't remember. We did.
We did.
So we'll say if it's not nil and the length of it is greater than 0, we will return the response and an error saying that the GraphQL, I cannot type those words in that particular order for some reason. GraphQL returned errors, something like that. So
would you really make that an else if, or would it just be two ifs?
I guess it could be both. Yeah, you're right. So
Yeah.
so this way we'll still return the response so you can actually see what's inside of those error objects, but we're also returning a non-nil error object so that when you're in main.go, when you check to see if the error is not nil, we will actually catch this log.fatal. So now, theoretically, if I did that right, we should be able to run this again, and we should get
We're
an actual error.
Ta-da!
only
Ooh, it's a
logging.
status one. Okay, so
Can we always log the whole request instead of just the data?
sure. So we can do a
A response, sorry.
println a response, yes, just so that we can see exactly what it's complaining about. Okay,
Nice.
so nice. Yeah, it
Hey.
looks like it returned that, and it's
Can I
actually
try
gave us a
something?
suggestion. Yeah.
Something Francis did earlier caught my attention was that they can get partial returns. So I was curious if like can we actually
Yeah.
do like one valid and one not valid and then run it? Is that correct?
Yeah.
Okay.
That would absolutely work. Yeah.
Okay.
Let's try it.
So
Yeah,
all
I'll run
profiles
that and we'll see what
should be
happens.
null, I think. Actually,
Right.
it might be that query is null in this case because query had returned an error, but let's find out what your server does.
Yeah, let's see what it
And
does.
we could always make surname, you know, have a Z at the end.
I see. So you know what happened here is because oh yeah, so it does look like it worked. So we got nothing for the data, and then we got an error. So it does look like it failed on that part of it and did not give us partial data back.
So I think let's try this because this should give us, yeah, I think this will give us what we want.
Okay. Should I run that?
Yeah,
Yeah.
let's try it.
All right. Huh? Not quite.
So this is
possible
not, I should also caveat that this is a GraphQL server that generates it based on JSON data with no types and stuff like that. So it's not like a fully fledged Apollo GraphQL server. Probably doesn't have all these bells and whistles. So maybe this is probably as good as it's going to get.
You know why it's not executing? Because it's not a valid query. There's a query validation step that runs first to make sure it matches the schema. And because this doesn't match the schema, it's not. If you made one of the resolvers throw an error, or say you have a connection and you can put in some invalid range or something that will throw an error, that's when we'll get partial data back. But this isn't even executing at all. Your server's going, you're giving me bad input, I'm shutting you down before I start using any of my resources.
Okay, that makes sense.
That makes perfect sense. All right. So if we reformat that to be correct, then we should be able to run this and get a good response back. There it is. All right. Very cool. All right. So we're going to, oh, I should probably have a branch for this, eh?
That would be a nice idea. Yeah.
Yeah, I'm not even going to name it Connor. I'm going to name it Rawkode GraphQL.
You need dash B.
We're Stella. Oh, yeah, I do need dash B. You're right. No, that's not a dash. My typing skills go to hell whenever I'm on.
I hope Francis and I are getting co-author rights on this PR too. By the way, just.
So we'll say basic working GQL client with Rawkode and recon bot. There you go.
Nice.
Oh, I gotta add stuff first though. All right. Woo. Hopefully you won't be able to see my my password manager pop up with. Oh, we're not even sharing my screen, so we're good.
Nope.
I'm worried about the terminal output. No, it seems okay.
Yeah, no, it hides it there. Cool. All right, so we have got the basic one working. So now we'll move on to the next step, and we want to take this Go client that we've created here, and we want to expose it as a host function that can be called by a WebAssembly module. So we're going to quickly go back to that capabilities struct, and we're going to add this as one of the available capabilities. Still cannot type that
forgot about
name.
all this. I was like, hey, we made the client.
Yeah. So we're going to set it so there's a function here for default capabilities. So we're just going to fill that in as well so that, by default, modules can have that GraphQL client available to them. The nice thing about Reactor is that if you want to pass in a custom version of this struct to a particular module, you can change it per module, and that's how you define which module is able to access which capabilities. So that's kind of a neat part of this. What is
Why
this
is it mad at
about?
us?
It is mad at us. Oh, because we need to make this a pointer. I will come back and clean some of this up later. Cool. So now we've got this capabilities object that contains our GraphQL client, and we're going to go ahead and expose it to the WebAssembly modules via a host function. So we're going to pop over to the WASM package, which contains all of our different host functions. And I'm going to create a new file called API GraphQL, and that's where we're going to meet. There we go. So our WASM is the Reactor WASM package, and we're going to need to define one of these functions. So I personally am just going to start by copying this one because it's going to be somewhat similar. So we're going to have this one, instead of fetch URL, what should we call it? Query, just query, I guess.
Yeah.
GraphQL query?
Yeah, GraphQL query.
Yeah. All right, GraphQL query. So in Go, you usually don't use a snake case or kebab case or whatever you call that. But in the Reactor codebase, I like to use the underscore to define that this is a host function so that we don't accidentally get confused later down the line, because I know I've done that a couple of times. All right, so for this particular host call, we're not going to need a method, so we're going to get rid of that one. But we are going to need a URL. But in our GraphQL client, we called it an endpoint, so I'm going to rename it to endpoint pointer and endpoint size. And then we're going to want to be able to pass that query. So instead of body pointer, I'm going to call it query pointer and query size. So as we talked about before, this will be the location of the query in the WebAssembly module's memory. And then this will be basically the length of that memory so that the host can find it. Now, this identifier.
This is a string.
Yes, it will be encoded as a string.
Yeah, go on. You're going to get to it.
Yeah. So this identifier is something specific to Reactor, and this is how we are able to run many WebAssembly modules all at once. Is each time you execute a WebAssembly module, it's given an identifier just so that we know which module's memory to go look at when we're pulling that string out of the memory. All right, so we're going to.
I guess we didn't implement it, but how would we do variables with that call signature? Yeah,
you're right. So for this is actually a tricky thing, and I actually don't particularly love the way I've implemented this. But in the HTTP call, for example, we actually encode headers for HTTP calls. By sticking them on the end of the URL with like a custom encoding that I really don't like the way that it currently works. So we're not gonna, maybe we won't replicate that here because I don't want to continue propagating bad practices. It's something that I've been meaning to improve in this code base. Yeah.
In the at Shopify, we've handled this with message pack, and so we just write message pack in and out, and so all you're doing is passing this pointer around for the string of the input and the output. There are limitations there too, and then we started. I don't know if I could talk about it, but there's a world in which we might want JSON, and because JSON can parse real fast in certain locations, and so we're like, okay, so maybe it's just JSON in and out.
Yeah, but I think there will be a future version that's based on JSON. The reason I didn't go with JSON in the first place was that Swift is one of the languages supported by Reactor, and working with JSON in Swift in WebAssembly is actually kind of broken, or at least it was when I first implemented this. So I went with a less nice but worked version than the ideal version. Cool. So we're going to
come around about eventually, you think?
Hopefully. I'm hoping that there will be some kind of WASI proposal that comes out soon that I may or may not be working on related to some of these things, but that's all I'll say for now.
Okay.
Cool. So we're going to add this little piece of boilerplate here. So this takes the identifier that I just talked about, and it actually gives us the WebAssembly instance that is associated with that identifier, and it allows us to actually go in and read that memory. So when this host function gets called, we're going to find the WebAssembly module associated with the identifier, and then we're going to read the memory out of that instance. So we're going to do instance.readMemory, and we're going to pass in the endpoint pointer and the endpoint size, and that's going to result in some bytes. So we're going to say the endpoint bytes is here, and then the endpoint is those bytes converted into a string. So we've taken the raw WebAssembly memory and we're going to convert it into something that we can actually use with our GraphQL client.
This can't
and then we're
fail?
going to basically so theoretically, yes, it can fail, but the read memory internally has some checks to ensure that nothing really bad happens.
Cool.
Yeah. So we're going to do essentially the same thing for the query. And this is going to be with the query pointer and the query size. So no, query size, and then the query bytes. So now we have basically the two things that our GraphQL client needs in order to actually do this properly. We are no, oh, right, we need to just import that. That's why this is complaining.
Hey, Gabriel, we're using live share.
Yeah, something that I've never really used a lot before, and it's really, really cool. It basically turns VS Code into Google Docs. It's really awesome.
It's working.
Yeah. So now that we have the two inputs that we need, and if we go back to our GraphQL client, we'll remember that we need the endpoint and the query as the input to our code that we wrote earlier. So we're going to take, now that we've read the endpoint out of the WebAssembly memory and we've read the query out of the WebAssembly memory, we're going to actually make that call. So we're going to grab the instance, has what's called a CTX or a context, and this contains that GraphQL client that we added before. So this is how capabilities are passed to the WebAssembly modules. That capabilities object gets given to the WebAssembly instance when it's executed, so that we can use those capabilities in a fun way. So we're going to call that do method on it, and we're going to pass in our endpoint and our query.
Shit.
Yeah, this is where the magic starts to happen. So we're going to get our response and our error from that, and I don't want to call it error because that would be the type, not the actual variable name. And now another part where WebAssembly is a little bit challenging and where I think the Reactor codebase needs some work done is that passing those error messages back to the WebAssembly module is not yet currently possible. So as kind of an interim solution, we're going to use this, this logger object that is available to just print the error message if one occurs,
So we
instead of... Yep.
No, so instead of writing like into an area of memory that they've reserved for a response, something like that.
So yeah, so eventually that is the plan. Reactor just doesn't support that yet.
Okay.
But it does support passing back just the successful response. So now we've kind of gotten to the point where we're gonna return -1 if this happens. So because of WebAssembly's limited, ability to have really complex types, the thing we're returning here is an int32. And when an error happens in Reactor, we return a negative number to indicate that it's kind of similar to Bash or a shell. When something bad happens, you return, something, a non-zero or a negative number to indicate that something failed. But if a successful call happens, the return value is actually the size of that response. So it's a bit of a tricky little interface that hopefully, the WebAssembly spec will make it a little bit less complicated over time.
This is
But
it's like my C code.
yeah, exactly. So, and that's this is basically the reason why I built Reactor, was so that it could hide all of this complexity from you, and you could kind of just use it as a normal library and not have to worry too much about it. All right, so we're going to continue copying some of the code from the HTTP version of this just to speed things along a little bit. And we're going to do essentially this. So what we're going to do is we're going to, the response is currently a struct, but we need to serialize that into something that can be written into WebAssembly memory. So we're going to actually convert that to JSON and write that into the WebAssembly module. So we're going to use that, the response, we'll call it response bytes to be consistent, is json.marshal. Again, we've seen this before. And then if the error is not nil, we're going to do the same thing as we did up here.
Out of curiosity, would it always make sense to write these bytes because the response is useful on error? Or is that a supported return?
So yeah, Reactor would need to learn how to do that, because their negative response code means that we can't tell it how big that response is.
I gotcha.
Yes. So what we're doing is we're converting it to bytes. We're using the set FFI result function to write those bytes into the module, and then we're returning the size of those bytes so that the module can then go and find it in memory and reconstitute it.
Cool.
Cool. So we have our, this is our host call, basically. We've now defined an interface that the WebAssembly module can use to ask the host to make a GraphQL query on its behalf. So we do need to do one little extra step, which I'm just going to, again, copy and paste. We need to create a wrapper around this host function to pass to the Go object of the WebAssembly instance. So this is just boilerplate code. GraphQL query, we'll call it, and we have to tell WebAssembly the shape of this function. So we have to tell it that what exactly the different arguments are, so that we can.
Not URL.
Yes, you are correct. So this is endpoint pointer.
Gabriel, this is going to run in Suborbital, which is a server-side framework for executing WASM. So it's not going to run in a browser. It's going to run as sort of these stateless runnables in the Suborbital project. Is it suborbital.dev? Is that the?
It is, yeah.
Suborbital.dev is the website. Yeah. So this is the Reactor project, which is the inside of Suborbital. That is the core WebAssembly execution engine that Suborbital is built on. Okay, so we're just creating a tiny little wrapper here that should just be 2 more seconds. And then we will do the query pointer and the query size. So this wrapper, all it's really doing, yeah, go ahead.
Can I teach you a trick?
Yeah, by all means.
Yeah, you can hit, if you click on a variable and you hit F2, you get a little rename, and you can, it'll go and rename everywhere.
There you go. There's the fancy stuff that I come on these streams to learn about. Cool, yeah. So this wrapper is essentially just taking this host code that we've defined and telling the WebAssembly instance about it and giving it information. So now that we have these and we've passed, I just want to double check to make sure we've passed the right things.
Is that the real capabilities? Right, because like the other capabilities, that's in Go, but it's not.
Mm-hmm.
But this one here is the one that actually gives it to the host module, right, or the guest module.
Yes. So this is given to the guest module. This calls our GraphQL query function, and then the GraphQL query function grabs our capability to actually perform the action.
Gotcha.
So there's a bit of a rigmarole that you have to go through, but that is what is needed to make it as flexible as it is. Cool. So the last thing we're going to do is we're just going to find the random point in the code where this is all added to the module. So we're going to take that that GraphQL query wrapper function that we just wrote, and we're going to include it in the host functions that are given to the module. And we should be pretty much ready to switch over to WebAssembly. So do we have any maybe comments or questions we want to address before we move on?
So Gabriel did ask if this is going to run in a browser, but there was a kind of a second part of that, which is why would we use WASM on the host? If you got a
that's a great question. So one of the great things about WebAssembly and one of the reasons why I chose WebAssembly as the technology to power Suborbital is that you can have multiple different languages coexisting inside of the same application. So people who use Suborbital, they often have different teams within their company that are comfortable with different languages. So maybe they'll have a mobile team that is used to writing Swift, or they'll have a web team that's used to writing TypeScript. And so they can actually write code in those different languages, and they can all coexist inside the same server architecture without you needing to do anything crazy to make them communicate with each other.
Okay, we also have a question from YMO, but I also point out that Noel has pointed out a bug in our code where we are returning fetch URL instead of GraphQL query. Where's that?
Oh, I see.
There we go. Okay, so YMO is asking about garbage collection, specifically Go and WASM, looking at lines 17 to 20, which I think are now 34 onwards. I'm curious about garbage collecting.
Yes.
Yeah.
That's right. So when we flip over to the Suborbital Rust library, you'll see some of this. But so WebAssembly itself does not yet have a built-in garbage collecting paradigm. That's again one of the proposals that is currently being put through the standards body is a garbage collecting proposal. But the currently the Suborbital host and guest code collaborate together to kind of do garbage collection. I don't want to use the word manually, but it is kind of manual, where the reactor is telling the guest module to clean up memory at the appropriate time, and then the guest code complies and actually does it.
Okay, I just want to check with you both. Like, we're at the hour now where we said we would finish. Do you want to go on for another 10 to 15 minutes and get this working? And is that okay for both of you? Yeah.
I'm cool.
Let's go for it.
Yeah, I'm excited.
All right, awesome. We'll try to power through the end here. So so we're going to switch over to Rust now, and we're going to
I'll pretend like I understand everything from here on out.
Hey, I think of the three of us, David is the Rust guru.
Oh no!
Hopefully. All right. So once again, we're gonna do some copying and pasting just to make this go quickly. So we're gonna define a GraphQL. Again, cannot type that word. We're gonna define the GraphQL. The GraphQL module within the Suborbital library, and we're going to define that host function as something available to it. So we're basically doing the mirror to the last the host call, where we're going to just expose it here inside of the module. So I think that should be good. We've got our endpoint pointer, endpoint size, query pointer, query size, ident. Perfect. All right. So now we need to create an actual usable function that somebody can go ahead and call. So we're going to define a pub fn, and we're going to just call it query to keep things simple. And we're going to take in an endpoint, which is an string. I don't know how people pronounce that in real life. And we're going to take in a query, which is also an str. And we are going to return probably a result, I would assume, of bytes of vec-u8, run error, which is a suborbital defined type. So
why wouldn't we want a JSON parse here?
So we will, to keep things simple, I think the caller is going to JSON parse because my Rust skills of being able to pass in a struct, parse it, and then all that stuff, I don't think I'm able to do that in the next 15 minutes. So we're just going to keep it simple. All right. So, we need to, I don't know why it's complaining. Oh, right. We need to actually use the full path for this. There we go. I think that should be good. Yes. All right. So it's just complaining that we're not returning at this point. So we should be able to do something fairly similar to this, where we want to take the endpoint and the query, and we want to convert that into memory that can be transmitted to the host. So we're going to try to do this in a fairly quick fashion. So there's a couple of helper functions inside of this library that will make it a little bit easier for us. And I just need to find them. Right, so we're going to be doing as slice and as pointer, I believe. Yeah, let's just do that. So we're going to say that our endpoint slice is the endpoint as a slice. Of course, that's going to complain. This is where David might need to help me here. Oh, right, we need to.
It's already a slice, isn't it?
You'd think. The body is. Oh, here it's
because it's
an
a vector. It's a vector of bytes. Yeah. So
I
you can.
See. So we need to.
Sorry to go.
We just need to do. How do you convert a stir to a vec? As vec, I think. Is that? No, we don't. We don't need that, right?
Oh.
You go ahead and take over.
Oh, there we go. So we can get as bytes, which is going to be. Yeah, you don't actually want a vector, right? You want so just as bytes.
We do want a vector. We do want a vector.
You do want a vector.
Yeah, because the vector is what we'll write into the WebAssembly module. Yeah, slice would work.
Okay, and what are we doing with the pointer?
So that pointer, right, exactly. And then we want to take query. That would be the endpoint pointer.
Oh, yeah. Oops.
We're going to do this twice, once for the endpoint, once for the query. There we go. All right. Look at that. This is why I wanted to do this on the stream.
No, I can't type. There we go.
There we go. All right, you got it. So now we are, so now we're going to actually make that host call. So now we're going to say that the result, we're going to let result size equal the so we have to use the unsafe directive here, because we're actually calling something that is being given to us at runtime, which is, in Rust terms, something unsafe. So we're going to say we're going to call that GraphQL query function. We are going to pass the endpoint pointer, and then we're going to do this would be endpoint slice.len, I think. Slice.len, is that, yeah, that's valid?
Yeah.
And then query pointer, and then query slice.len. For some reason, I keep typing Z instead of C. And then we're going to pass in that ident as the last parameter. And that should, cannot find GraphQL query in this scope. Why not? Did I misspell it?
It looks like it does say there's a different. It's hard to do when I'm
sorry.
talking.
I'm scrolling around. That's my fault.
There you go. You just can't spell.
Oh, well, that would explain a lot. All right, cool. Oh, right, we need to convert these to as I32 and as I32, and this cannot find ident in scope. Oh, that's right. We need to do super. It's a super call. Super state ident. That's what it is. Apologies for the copy and paste. I wanted to do a lot more of this live, but we are running out of time. All right, so we're gonna think. Oh no, the semicolon will go at the end. Okay, there we go. So now we've called the host function, passing it the pointer and length for each of our 2 parameters. And then we're going to take that information and we're going to actually do something fun with it. So we're going to use this this helper function that's included in this library to accomplish that in a way that's not super gross. So we're going to basically read the memory from that the host has given back to us and passing that size as the parameter. And this is going to give us either the bytes or an error. And so because the return type of this function is either bytes or error, this kind of just satisfies it. So I believe at this point we have everything that we need in the library. So should we try to actually use this thing?
Definitely.
All right. Hopefully we can do this in a quick 5 minutes and be done for the day.
About there.
All right. So we're going to create we're going to go inside of this in this test data function package, because that's where I keep all of my testing stuff. So we're going to use the Subo CLI to create a runnable called let's say rs GraphQL. Still cannot type that word, and we're going to put it inside of our WASM. Our WASM slash test data, I think. That should do it. All right, so now we have a new, this is a reactor runnable that is written in the Rust language. And we should now be able to take advantage of that GraphQL function we just wrote within here. So we need to do a quick little trick just to make sure it's importing the right version of the library, because we want to use the local version instead of a version from the cargo package manager. So we're just going to edit cargo.toml real quick to trick it into using the local version. And then we're going to get to work. So hopefully, if it accepts all of this, we should be able to use it. Hopefully. Cargo.toml. Hopefully. Sometimes I need to restart my my Rust server in order for it to like that after I do that import. External location does not exist. It seems to like it, but for some reason it doesn't. Well, we're going to just try it anyways. So we are going to we're going to import the suborbital GraphQL. It knows it's there, so it's obviously just complaining for no reason. Need to put something on there. I don't know why it doesn't like that one, but it likes this one. But anywho, so we're going to call query, which is from that GraphQL one there. Do you want to fill in the endpoint and the query there for me, David, like you did in the other example, or should I just copy it?
That's all right. I think that's right.
Should I probably have an HTTPS on the front of that?
Yeah.
I think.
All right,
Probably.
fussy pants. And do we need a response?
And then, yeah, so we need to put that in something. So that is going to be a result type. And so we're probably going to want to match on it. Yeah. Time for a speed round.
I don't know what this is yet, so
It's a response, right?
what all right, okay, yeah. Response. Blah.
Yeah.
Definitely print it. Do we have a logger?
We do have a logger. Yes, we do.
Does println work here?
I have no
It will
idea.
not.
Okay.
Oh, it's okay. I'll fill it in after that.
There you go.
So we'll use suborbital log for this, which will give us some actual. So we're going to log in info, I think, not into info. No, it would just be info. Yeah, lowercase. So we'll just log that. Help me. Oh, I guess we actually want to log the string version of that response, don't we? So we'll want to do response. No, we'll want string from. Is that right?
Mm-hmm. Yep. Well, it depends what
Yeah.
response is. It's just bytes, right? So
And
it should be
then
okay.
to str. Yeah, I think that should work. It's not yelling at me, so that's decent. And then we will log, if we get an error here, we will log that e dot e should have a message, I think, if I remember correctly.
Dot message
Query.
spelled properly, I believe. And an error type, right? Or is this your message?
Sorry? This should be, this will be a generic error message because, yeah, there's not much we can do there. All right. So it's only yelling at me up here, but I feel like that's a fake error because
there's a restart.
It's not complaining about anything else.
If you pull up your command palette, you can restart.
Yeah.
Okay, what's it called?
I've
Rust
definitely had to do
language
the
server.
RLS.
Yeah.
Yeah. Oh, it could be that it's that the library has an error because it seems like it does. Why doesn't it like us here? Do I have to return here? No.
No, because there's no semicolon, so we don't have to return. Although it is telling us that we're not returning. Oh no.
Right. It's complaining about a bunch of different stuff here.
Well, it's complaining.
Oh.
Yeah, we got the U size I32.
We're so close.
We are so close. Here, let me compare it to the other one because that's how I usually write code, is just compare it to something that I've done in the past that works. Let's see. It doesn't seem to complain here about that. We're doing the same thing here. So I wonder why this one would be complaining about it. Does that have a comma? Yeah, there's supposed to be a comma there, right?
Did you restart the server, the language server?
Yeah, I just did that. Doesn't seem to like it still.
Let's try and let's pretend that it returns that. And now it's complaining about this. Oh yeah, if we can just ignore that now.
Hopefully.
Okay, so now it's only complaining about our U size in I32.
Yeah.
Just trying anything.
We do have the as I32, yeah.
Yeah, I'm not sure why it wouldn't like that.
It says you can only convert it by doing try into an unwrapping because that pew size might be larger than an I32, so it might panic.
That's strange. What do I do down here? Yeah, .len as I32. That's what we do down here. Did
I get that right? Method not found on new size. Okay, thanks.
Gotta love it when you're right at the finish line and it doesn't like it.
Yeah.
Well, do we define the inputs of GraphQL query different than we do for the other thing?
So yeah, our endpoint pointer is a const-u8 and our size is an i32 for each of them. So endpoint pointer is a const-u8, which is why it doesn't mind that. But then for some reason,
Okay, let's try. You said it was potentially a vect, so I'm going to force it. And what was it, a vector? U8, right?
yeah.
Into. Does that help?
Oh, sorry, I'm scrolling
No.
around. Yeah, let's see. When we take this URL and we convert it, what do we do here? We do URL string as str.pointer and then URL string.length. Why don't we try just copying this?
Oh, you're
here?
using uppercase strings, right?
No, these are ampersand stir.
No, but down the bottom you have this follow thing is. I'm going to turn you off now.
Yeah, that's okay. So we'll take.
Yeah, you're using format here, right? And string from. So these are uppercase strings that you're using length on and slice.
So I see. Okay.
We could always do a string from endpoint and then as slice. Why is it complaining about that?
As slice is not a thing.
Was that not what was just done here?
It might be as vec.
URL string. Oh no, you're just using a string, right? Okay, sorry.
Yeah.
And then that has a length as an i32. And this is, so that should be endpoint slice, right? Why do computers hate us?
Very, very good question.
So we were trying to pass a pointer and a length of the endpoint here, right? That's our mission. Okay. So we've got the as pointer, which is fine. So I'm not really sure if we actually need these.
And maybe not. If we just do endpoint.len.
Yeah.
You probably still need an i32 though.
An i32, yes, a new type. But
it's not. It's still complaining about the U size, even though we've casted it.
Okay, so endpoint size equals endpoint.len. I mean, does that work?
Let's find out. Endpoint size. Yeah, for some reason it likes that, but not the other way around. All right, so let's do query dot as pointer here, and then we can you add the same thing for query there? All right. Oh.
What's it complaining about?
Semicolon.
Expected
that. Something with my
I think it's
Rust.
your language server thing, right?
Yeah, I've restarted it about 4 times already.
Can we just compile it?
Unfortunate. Yeah,
I think we might be able to. Yeah, that's basically what I'm coming to at this point. So if we try to sudo build, we want to build our WASM /test data, right? What is this called? RS GraphQL. RS GraphQL, and we're going to use the native toolchain. Let's see if it complains. Why? Oh.
No such file, test data, GraphQL.
RWASM, test data, RS GraphQL. Did I misspell that? Okay, why don't we, here, we can just build them all. Easier than trying to do it with an individual one. So this is just Subo is going to go through and build every single piece of test data, which should only take 10 seconds or so.
Yeah, you still can't spell GraphQL, that's why. You
Probably,
got
yeah.
GraphQL in the path.
Oh my God. All right. Well, that makes sense. That is going to be my legacy from this stream, is just my inability to spell the words GraphQL. All right. Should be just about done here.
Ah, I can't wait. I'm just waiting for it.
Oh, yeah, there it is. So now it's complaining.
3 errors.
Oh, I know what we did.
Oh yeah, we've used toString instead of as string. And you've called an error function in librs. But I'm going to follow you again.
Oh, I see. I see. Okay. Right. We can't use that. We are going to instead. Oh, yeah, that's right. We're going to do, we want the error function from the logging package instead of the error macro from the, yeah, that makes sense. Okay, so now that I know that I've misspelled that, let's try to rebuild just that one in particular. So if we build our WASM / test data / rs - gra QHQL, because apparently that is how I've done it. All right, so it's complaining.
Tab
Oh, I
completion.
just passed. It's just complaining about our inputs there. So if we, instead of toString, it should be as stir apparently. And then,
No, I think it's complaining about we've got
because response is vec, so we're converting it to a capital string, and then we're converting that to a stir. So I think that's what it wants.
Okay, let's try.
Yeah, we'll see. No. Oh, that's right. We can't. I think I have a util that will help us here. We can do util.
It's because we don't know what encoding the vec is.
Right. We want toString, and that will be response, and then we'll do as stir from there, and then message is apparently something unknown. E.message. That should be run error. Yeah, that one should be okay.
Well, what type is E? Because I'm not getting any annotation.
E should be a run error.
Okay.
Yeah. Assuming we've done our, run error.
And run error's message is an uppercase S string, so.
Right, so that's why, that should do it. Okay, try that. Hey, there we go. It built. All right.
Hey.
So now
Run it.
we should be able to run this module and actually get something usable. So now we're going to switch over to the fastest way to get this running is to just use a Go test. So we will, let's find one that's doing this properly. We will copy this one here, and we'll create a brand new test called, oh, it really didn't like that. What did I copy wrong here? I want to copy this whole thing, and we're going to create a new test called test, let's say GraphQL QL runner with All right, so we're going to import the rs-gra. make sure I spell my typo correctly. GRA QHQL / QHQL.WASM. All right, so now we're going to pass in, well, it's already running the query the way that we want, right? So we don't need to pass
Yeah.
anything into it. We can just pass in an empty string there. And then assuming everything goes correctly, we should be able to say println the response, which is an interface type, and we want to convert that to bytes.
Would this be the logs?
This would be what it returns. Oh, you know what? You're right. It's logging. So we don't really need to actually do anything here.
Okay.
Because I don't think we returned. Yeah, we just returned hello, in the module there. So we can just do nothing here and see what happens. We're not even going to use the response. Okay, moment of truth. We're going to run this.
Cross your fingers.
See what happens. Will you be able to see that output?
No.
Oh, I don't think you can. You can't see my output. Okay, I'll run the test command manually, and then you should be able to see it. So if I switch over to that terminal, you can see that, right? Yeah. Okay.
Yeah.
Cool. So let me just format this correctly. We're going to make it verbose, and we're going to run the local version. And there it is, our data.
Hi, I recognize that name.
All right.
We did
so that
it.
was a very long walk. But we got there in the end.
Awesome.
Oh, that's fantastic.
Yeah. So we're using Reactor to load this WebAssembly module that we built, and then we are calling it, and that WebAssembly module is making a query to David's GraphQL endpoint.
So,
that is passing the query to the host. The host is doing the request, passing the response back to the module, and then that is getting logged by the module. So that was a very long walk, but we got there in the end.
That's a beautiful thing.
Yeah, that
was
that
super
WASM
cool. File, we can like delete the Rust, keep that WASM file, email it to a friend, and they can run it, and it would go and hit api.rawkode.dev, and as long as it had the right capability functions, then it would be able to log, do the GraphQL, and give us that output.
That's all right. Exactly right. So you know, when you at the top of the Rust file, you saw we were importing the different modules from the Suborbital library, and that was basically importing those capabilities that we had written earlier in the stream. So it all comes together, and we were able to conquer the dragon.
It's a beautiful thing. Oh my goodness.
All right. Well, that was very, very cool. I really enjoyed that. I learned an absolute ton. So I'm going to say thank you, Connor. Thank you, Francis. It was a pleasure to sit and work through that with you both. Any last words?
Yeah.
I don't think so.
It's a lot of fun.
I'm going
to drop a link for Gabriel into the Discord chat about some other capabilities we're doing with WASM, or people out there are doing with WASM, where like, because of the nature of it, you can like boot a program and then pause it, and then use it to execute, input from there. There's like all these, because of that isolation, there's this entire world of things you can do for very fast computing. And I was just like waiting for a game to install the other day, and I'm like, if this was WASM, we could like stream it, like I could just start playing it, because they just start reading the memory from the beginning, right?
Yeah,
we're not in that world.
It's pretty
yet,
cool,
but...
and the portability of it is awesome. Like if a browser were to expose that same GraphQL query host function, you could take this exact same WASM module, run it in Reactor, and then also run it in the browser, and that's the portability that you don't get with any other technology. It's really quite cool.
Yeah.
All right, we will leave it there, but we will fill up the description with more links to more awesome stuff on Suborbital and others. Thank you both again.
Yeah.
Have a wonderful evening, and hopefully I'll see you both again soon. Thanks.
Yeah,
Thank you,
cheers. Thanks, everyone.
Bye.
Have a good day.